SCI Access, May 11, 2024. 3D Printing and Astronomy for Students with Visual Impairments, the STEM Career Exploration Lab. Dr. Thomas Madura.
So I want to, as I'm getting set up, I would like to thank the organizers of this conference for inviting me to participate. It was as a result of attending the first SCI Access in 2019 in person that I was able to connect with Dr. Tiffany Wild at Ohio State, who unfortunately couldn't be here today, but who was an integral part of helping this project get off the ground and get NSF funding. So on the slide, I'm just showing a few images of some of our 3D models, including a model of the sun, some models of galaxies, and a model of a constellation in 3D. My collaborators are Carol, Tiffany Wild, David Hurd, Lindsay Bartolone, Noreen Grice, Joy Harris, Ellen Hoke, and many, many others around the country that I haven't had a chance to include, but we do partner with a number of state agencies for the blind and schools for the blind around the country. So the first slide is actually just a little bit of an acknowledgement to NSF. So this material is based upon work supported by the National Science Foundation under our Innovative Technology Experiences for Students and Teachers ITEST grant number 1949458. And any opinions, findings, and conclusions or recommendations expressed are those of us, the authors, and not necessarily reflecting the views of the National Science Foundation. Okay, so I think we are all kind of aware of the issue, which is nearly everything we know about the universe comes from studying light and performing computer simulations. And most astronomy data consist of 2D images or spectra, at least historically. So the question has been, how do we teach the wonders of the universe to those with visual impairments? And I think it's important to emphasize the question isn't, can we teach the wonders of the universe? We should be doing everything that we can to teach the wonders of the universe to everyone. So the question is what may be the best ways? What are different approaches that actually work to teach the wonders of the universe to everyone? So with this project, we started something called the STEM Career Exploration Lab, or CEL for short. The purpose and goals are to use 3D printing technologies, specially designed tactile models, and astronomy to help high school students with visual impairments, VI, explore STEM and STEM careers. And on the right, I have an image of one of the top, an image of one of the agendas for one of our workshops. And then on the bottom, I'll talk about this more in a second, is a picture of some students actually assembling a desktop 3D printer. So we also introduce students with VI to professional role models with VI who have successful STEM careers. And the whole idea is to help motivate students with VI to pursue a higher education and career in a STEM field. And we are using 3D printing and astronomy as kind of the hook to get students interested. The other thing that was really, really important and where NSF comes in is we wanted to investigate if 3D printed tactile models can actually help students with VI really learn STEM and astronomy and really get the concepts. So there has been a kind of a lot of anecdotal evidence that 3D printing can work. And there have been a few studies in some other fields, but no one had really done like a really rigorous, as far as we were aware, really rigorous detailed research study on using 3D printed models for students with VI to learn astronomy. And so we wanted to test this hypothesis. Okay, so the backbone of our program is actually engagement with teachers of the visually impaired, abbreviated TVIs, and high school STEM teachers via what we call Educator Partner Institutes, or EPIs. So we don't just work with the students, we also work with the teachers to help us develop our lessons, to develop our 3D models, and to thoroughly test everything. So we test everything with the educators themselves, and then we also test everything with the students to get a community-based feedback approach to our models. I think it's incredibly crucial to work with any community that you are trying to serve or trying to get interested in STEM, because their feedback is crucial to us getting it right. And also it shows that we value their feedback on an equal level, right? We are not any better than they are. And in fact, they, I would say, are much better than we are at understanding exactly what is needed in terms of trying to teach STEM to different groups of people, right? So our EPIs are coupled to the student STEM CELs, which employ various hands-on activities, talks with STEM professionals with VI, and STEM field trips, and I'll talk about these in a little more detail. And then the TVIs and high school STEM teachers work together to address key barriers to success in STEM of students with VI. So the TVIs act as the kind of experts in teaching students with VI, and then the high school STEM teachers, who often are not trained to work with students with VI, become aware of some of the unique issues and the just kind of the unique situations that arise or may arise working with students with VI in terms of lack of materials, and then the STEM teachers can kind of help the TVIs who are not STEM experts be kind of brush up on their STEM background. So it's a really nice working relationship where everyone works together to whoops, I should have gone back. And then I apologize, I skipped slides. There we go. So on the slide, the images that I have are at the top on right, I have a group of teachers who are participating in an activity on learning about lunar phases. So they're standing in a circle, each holding a little model of the moon on like a little stick. And then the bottom two photos are just some images, group photos of some of the different cohorts of teachers that we have worked with so far. Okay, so let's talk about the students. So on the slide, I have some images, like they're just images of some of our groups of students that we've worked with in past cohorts. One is in front of a space science and planetarium. So the students, summer camps are a week long. We have 5 to 20 students with visual impairments. They age range is 13 and up, high school academic level. They come from 12 states spread around the 4 main US Census regions, West, Midwest, Northeast, and South, representing all areas of their home state and covering essentially all of the main demographics of the home state. So we wanted this as a part of our program because we wanted to show that this wouldn't work just for some narrow local region of the country. We wanted to get as much feedback from as diverse of a student population as possible. And the teachers also come from these states as well. The students are recruited by the educators and by the schools and state agencies for the blind. So we let them handle the recruitment. They stay on site in dormitories while some students participate as day campers. The students in the evening have planned social and recreational activities. So the camp is not just the 3D printing and STEM during the day, but it's a lot of fun activities at night and going to sporting events or doing other types of activities in the dorms, just trying to make it as fun as possible for the students, and so they can work with like-minded peers who are also interested in STEM. And then we also do a lot of data collection. So we do pre and post evaluation data, including a number of accessible online surveys. We do in-person interviews. We do astronomy assessments. And we gather all of this data in order to measure the program effectiveness and also to answer our various research questions, and then obviously to improve our materials as much as possible for eventual future release. Okay, so let's talk a little bit about the camp, the summer camp itself and the lessons. So it's a 5-day camp that uses astronomy, hands-on activities, sound, and assistive technologies, including 3D printing, to help bolster STEM skills and interest. We try to focus our lessons on spatial thinking, which can be particularly important for students with VI, who usually use auditory and haptic perception with spatial thinking to help form mental images and make sense of the world around them. And then the first lesson of the week, which is something that we are incredibly proud of and is our unique project centerpiece, and as far as we know is something that nobody else has really done, is the 3D printer build. So I will show, so there's a series of images on this slide, but what I will do is I will kind of walk through what these images are. So what we do is the very first activity of the day, since the students are working with 3D models, 3D printed models, is we purchase a 3D printer kit. And we had to kind of develop this from scratch to figure out how to get it to work in terms of as an educational activity. But it's a hands-on engineering task where students with visual impairments work in pairs or groups of 3 to actually assemble and calibrate and learn how to use a desktop 3D printer. So we've developed a set of special Braille instructions, as well as large print instructions and also audio instructions. And we have the parts laid out in a specific sequence with trays to hold the bolts and the Allen wrench tools. And then the students work together while we kind of just supervise and help them with any questions or issues that they may encounter. And then we let the students go at it. And the students assemble the 3D printers, and then we explain how they work. And then by the end of the first day, as you can see, as is demonstrated in the images that are available in the bottom right, we have pictures of the assembled 3D printers by the students. And then throughout the week, we show the students how to use the websites to find 3D models that they may want to print. And then the students, we will assist the students in printing their 3D models over the course of the STEM week. And this has been a wonderful activity, and the students love it. They love getting hands-on, learning about the technology, learning about how the printers work. And it has been, in my opinion, an incredible success. And we are hoping to publish the results of this soon. And now on the next slide, I just have a series of images of some of the 3D printed models that the students have printed. So I'll just describe these real quickly. One of them is a copy of a meteorite sample that was laser scanned. It's a 3D scan of an actual meteorite sample. Then I have some images of some little like anime cat figures, a 3D print of a little piano, the Batman logo, a 3D printed model of the Death Star from Star Wars, a bust of Darth Vader, an astronaut in their spacesuit, a little heart-shaped box that says "I love you" on the lid, a rose, a race car, and an image of a little dog. So these are all examples of 3D printed models that students have printed at our camp. Now, as far as the astronomy lessons, we cover a wide range of topics. So the first is lunar phases. So I have some pictures of students participating in the lunar phase activities, standing around in a circle, holding models of the moon. We also do an activity on light and energy using sound. And so there is a large touch piano. It's a very, very large piano. It's like a folding kind of toy piano, and we use that to teach about light and energy and spectra. And then we have other activities using slinkies, and there are some pictures on the slide showing students using a slinky to learn about waves. There is an activity we do on the sun, and I'm showing an image of a 3D printed model of the sun showing the sun's internal structures and layers. And also we have some thermoform or tactile 2D relief images, diagrams of the sun with Braille, and I'm showing an image of that on the slide as well. So we have a lesson that involves the sun. We have another lesson that's called 3D constellations. It's a 3D printed kit that contains a large number of pieces, and students assemble the model in 3D to learn about the structure of constellations in 3 dimensions. And this is a very hands-on quantitative activity because the students need to learn how to use Braille calipers and digital calipers to measure the parts and assemble the model. We have an HR diagram activity that's a plotting activity to plot data. The star clusters that Carol talked about, galaxies that Carol already talked about, so I'm just showing some pictures of those. And then an activity on the cosmic microwave background radiation with a 3D print of that and some Braille tactile images of that as well. We also take students on field trips to science centers, planetariums, STEM businesses. One of the places that we went was in South Carolina was the Boeing factory, where they build the 787 Dreamliner commercial aircraft. And so on the slide, I just have a number of pictures of students at the various different locations, including inside observatories at Boeing, at the Chabot Science Center, NASA Ames Visitor Center here in California. And then another thing that is really, really important is having role models for the students. So we have students meet role models who are blind, who have successful STEM careers. And on the slide, I'm showing images of some of our speakers, including Ken Silberman of NASA, Derek Strick, who runs the 3D printing lab at the South Carolina Commission for the Blind, Nick Bond, who is an astronomer with visual impairments, who does the Tactile Universe project, and then Paralympian medalist John Kusku, who is a high school math and physics teacher with visual impairments in the state of Michigan. And then the students learn about various STEM careers, including astronomy, physics, 3D printing, engineering, biology, chemistry, geoscience, computer science, science education. So these our STEM professionals come, they talk to the students. We do open Q&A sessions between the students and the STEM professionals, and those are also great times for the students because they get to ask all kinds of very interesting and amazing questions. Okay, so in the last couple of minutes as I wrap up, these are just some things to consider and things that we have found when we're trying to develop this project. And I think it's something to keep in mind if others want to try to kind of like continue with this type of work. So one thing is that students with VI have a wide range of VI, and one should accommodate all students. There are students who may be completely blind, while there may be others who are low vision or just maybe starting to lose their vision. You need to make sure you have materials available for all students so that everyone can participate equitably. Students with VI will often require other accommodations. So again, this just goes back to the first bullet point, which is you want to make sure that you accommodate all students where they are, and you know, just do whatever you can to help them to have as pleasant and enjoyable and interesting an experience as possible. Students with VI often do not have the same life experiences and background as their sighted peers, so you need to be real careful when writing lesson plans about the assumptions that you make about what students with VI may or may not have experienced. So one of the things that we've done is we just assume no background knowledge in astronomy or STEM, and we just let the students ask any questions that they have, and then we just pursue that, and again, trying to make this as fun as possible for the students. This is something I think a lot of us know already, but I'll repeat it here. There's a dearth of resources in STEM for students with VI, and so many materials must be developed from scratch. And finally, 3D printed models can work, but often not entirely by themselves. A wide range of materials is needed, including 2D and 3D tactile models, braille, large print, audio, etc. Okay, so some key research results to date, and then I'll wrap up. So students with VI understanding of the meaning of 3D printed objects increased with this project. We have evidence to show this. Given instruction on how to interpret the prints, students could ascertain the data represented. For example, students thinking in the pre-test interviews that a 3D printed model of a galaxy was a tree or the ocean, but recognizing it as a galaxy in the post-intervention interviews. Overall, students with VI conceptual learning and understanding of astronomical phenomena increased as a result of participating in the project. Students with VI's understanding of the components of an HR diagram greatly increased with this project. Overwhelmingly in the pre-test interviews, students didn't know what an HR diagram was or anything about the data it represented, but post-test, their knowledge levels significantly increased. But what we did find was that students with VI still struggled with abstract concepts of scale when discussing very large abstract concepts such as a galaxy or planetary orbital paths. Now, I want to emphasize that this is something that all students struggle with. So this is not unique necessarily to students with VI. All students will struggle with this concept because these are large abstract concepts, and humans in general just have a difficult time imagining extreme length scales that we don't encounter in our daily experience. Okay, so as Carol said, some of the 3D models are freely available on NASA's and Carol's websites, so the URLs are being shown here on the slide, and for the sake of time, I'm just going to go through this real quick. So the next steps, write up and publish our results, share what we learned, including our 3D models and lessons. So the plan is once the project finishes, over the next year, we will make everything that we have developed freely available, and then apply for more funding to scale up for more students and teachers in more areas. So thank you very much. And if you would like to reach out to me at all about any of this, my email address is on the screen at thomas.madura@sjsu.edu. Thank you very much.
Thank you so much, Thomas. Thank you for that fantastic talk. We do have a few minutes left here, so if anyone has questions, do feel free to submit them through the chat. One question we have is, where is the summer camp located, and are there any students who are blind with additional cognitive impairments?
Yes, so those are, and I'll stop sharing my screen. So the camps are held throughout the country. We do them in multiple states. So for example, this summer, we are doing 9 week-long camps in 9 states, including Ohio, California, Kentucky, and I'm sure I'm going to miss some, Pennsylvania, Michigan. We do them in as many different locations as possible. And we coordinate, again, with Schools for the Blind and state agencies for the blind. We partner with them and they act as the hosting facility. In terms of other issues, yes, we have encountered some students who do have what was asked of the question. but this hasn't really been an impediment for us at all. Like I said, we try to meet the students where they are, and we do everything that we can to make it as enjoyable and meaningful an experience for all students as possible. So the only real restrictions for participation in our program are you need to be a student who has a visual impairment, and you because of the way the NSF funding works and because the way the state agencies work, we're looking really at the high school level, because we're trying to motivate these students to apply to college, and we're trying to get them kind of in that particular age group. But otherwise, we don't have any other real restrictions.
Fantastic.
Yeah.
And one other question from Melissa, who asks, are there ways to help a student pay for camp? Any resources or programs?
Our camp is free. There's no cost. There's no cost to participate in our camp. Every once in a while, depending on the state agency, if they have their own rules or regulations, they may charge a nominal fee of maybe like $20 a night to help cover staying in the dorms or something, but we do not charge anything. And also another thing I should have mentioned, the 3D printers, after they are built, we donate those to the teachers so that they can be used in their local school districts as they see fit. So the teachers that we partner with are allowed to keep and continue to use the 3D printers that we provide as a part of this program.
SciAccess. Learn more at www.sciaccess.org.